Imagine blowing up two identical balloons, one filled with hydrogen, the other with oxygen. You use the same volume of gas under the same temperature and pressure. But here's the question, do they contain the same number of molecules? Yes, thanks to a concept introduced by Avogadro. This simple but powerful idea became one of the foundations of modern chemistry. In 1811, Italian scientist Amedeo Avogadro proposed a groundbreaking law: equal volumes of all gases under the same conditions of temperature and pressure contain equal numbers of molecules. Let's spell that out. Equal volumes means comparing the same space, like 1 liter versus 1 liter. Same conditions means temperature and pressure must not change. And the key point, the number of molecules inside those equal volumes is also equal no matter what gas you're using. This is known as Avogadro's law. Let's use the example straight from your book. Hydrogen reacts with oxygen to form water. The equation is, that's one molecule of hydrogen gas combining with half a molecule of oxygen gas to form one molecule of water vapor. Let's scale this up using Avogadro's law. 2 liters of hydrogen gas, 1 liter of oxygen gas, give 2 liters of water vapor. Equal volumes means equal number of molecules. So this volume-based reaction is also a molecule-based reaction. This law helps us directly link volume and number of molecules. Why is Avogadro's law so important? It helps in inflating balloons. No matter which gas you use, the number of molecules depends on the volume, not the type. Car airbags use gases that follow Avogadro's law, so deployment can be controlled by knowing how much gas volume is produced. In industries, gas production and storage is calculated using this law to avoid overfilling or underestimating needs. Bottom line, if you control the volume, temperature, and pressure, you also control the number of molecules. Let's now express Avogadro's law mathematically. It says, volume is directly proportional to the number of moles of gas if temperature and pressure remain constant. V equals K multiplied by N, where V equals volume of the gas, N equals number of moles, K equals proportionality constant. This means, if you double the number of moles, volume also doubles. Simple and powerful. Let's solve a quick problem. Question: a gas occupies 6 liters at 0.25 moles. What volume will 1 mole occupy under the same conditions? Step 1. Identify the known values. Initial volume is 6 liters, initial number of moles is 0.25. Final number of moles is 1 mole. Final volume is unknown. Step 2. Use Avogadro's formula. We apply the proportional relationship V1 divided by N1 equals V2 divided by N2. Step 3. Substitute the values into the formula. 6 divided by 0.25 equals V divided by 1. So, 6 divided by 0.25 equals 24. Therefore, V equals 24 liters. Final answer: 1 mole of gas will occupy 24 liters under the same temperature and pressure. At standard temperature and pressure, abbreviated as STP, 1 mole of any ideal gas occupies 22.4 liters. This value is a direct result of Avogadro's law. It allows chemists to convert moles to volumes and volumes to moles using a single, reliable number, 22.4 liters per mole. So if you have 2 moles of gas at STP, the volume is 2 multiplied by 22.4 equals 44.8 liters. Let's wrap it up. Avogadro's law links volume and number of gas molecules. It works only at constant temperature and pressure. The equation is volume is directly proportional to moles. Real-life uses, from lab calculations to airbags and gas cylinders. 1 mole of gas at STP equals 22.4 liters. And remember, this law is a cornerstone of stoichiometry and leads us to the deeper concept of the mole in chemistry. In the next video, we'll explore how to use this law along with molar volume and ideal gas equations. Stay curious